Good morning, everybody. I hope you're not dozing or sleeping anymore and hope you're excited. Before I start, I'd like to introduce myself. My name is Ralf Wondratschek and I work for a company called Evernote. Evernote is basically a note-taking app, but of course provides a lot of more features on top of that. If you haven't seen it, those are two little impressions of the app. But let's get back to the topic, Doze. The reason why I'm standing here today is probably this little icon. Nobody likes to see it and it always appears at the worst time. And sure, there are a couple of reasons for that. Display sizes increase every year and the devices need more power. But there's also a lot of things we could do as developers. One of those things is background work, tasks which you need to do over and over again. And they have a lot of potential to save battery. And of course, we don't want to waste battery unnecessarily if we don't need to. Then another reason what has changed is that Android introduced a couple of power-saving modes so that the battery lasts longer. And the first ones were introduced with Android Marshmallow, and those also had implications for us as developers. We needed to change our applications and adjust accordingly. Then also a couple of weeks ago, Android O was released, and it had even more changes than Doze and App Standby. And if you try to implement this properly, then you will notice that it's quite a headache to do this for every device out there correctly with every Android versions and every manufacturer, and it's really challenging. So let's start and go a little bit back in time and start with Doze and App Standby. I could say a lot of things about Doze, but really this graphic is showing what's going on. So the typical use case is that you use your device, you're interacting with some apps, and then after some time you turn off the screen and put the device on your desk, and then you don't use it at all. What will happen with Doze now is that after some time, usually it's about an hour, the device will go into the Doze mode, and you see this here. So in the Doze mode, the device is not only reducing the CPU frequency, but it's also turning off network connections, and it stops apps from running. The device spends some time in the Doze mode, and that saves a lot of battery. Then after another hour, maybe a maintenance window starts. Then the Android system is looking for applications which need to do some background work. It starts those applications, and once they are done with their background work, the device goes back into the Doze mode. And in Doze mode, the time frame increases over time. This keeps running until the user turns the screen on again. And then everything is starting from the beginning. So the Doze mode was introduced with Android Marshmallow, and it was really about the long idle battery life. And one really typical use case, for example, is the tablet. If you use your tablet in the evening, then the next morning you leave, and for the whole day you are not using the device. And of course, it shouldn't waste any battery during that time. Then with Android N, they introduced another Doze Lite mode, but from a developer perspective, it wasn't that much different. The difference only is that the Doze Lite mode already starts when you put your device into the pocket. So for the original Doze mode, the device should be lying flat on a table. And the third power-saving mode is App Standby. And App Standby is intended for those apps which you don't use that often. For example, you install a game and you play the game, and then you don't open the app for a week or 2 weeks at all. And of course, during that time, the app shouldn't waste any battery. And then, of course, there are special cases where you can interrupt Doze mode. So like I said, during the Doze mode, your app is not allowed to run. And there are ways to prevent this. For example, we have the GCM or FCM messages. So, for example, your Messenger app, of course, you want to receive a notification even for the devices in Doze mode. And of course, there are other exceptions, and for example, the special APIs, and we will get to them later. Then Android O was released. And in my opinion, Android O came with one of the biggest changes. One really big change were the new background execution limits. So we always knew for Android for the fact that one app could be used in the foreground and other apps are doing some background work in a different process in the background. This has slightly changed. So the problem was that the user was never aware of if an app is consuming a lot of resources in the background. And now with Android O, you have to use foreground services instead of background services. A foreground service is basically a background service, but the user sees a notification on the screen. And the user is aware of it, that the app is running and doing some stuff in the background. And Android O is now more restrictive, and it's trying earlier to stop your process if you're using a background service. For example, if your app is currently in the foreground, the user is using it, then of course you don't need to show a notification for your background services because the user sees that your app is running. And if the user now leaves your application and the app goes into the background mode, then it's very likely that the Android OS is stopping your process again and also your service. So the way you should handle this is that you should switch to a foreground service again and stop your background service. And then another change is that you, on Android O, you can't even start background services while your application is in the background. Instead, you will receive now an exception and your app will crash. Another really important change were the broadcast removals. So Google introduced a whitelist, and a couple of broadcasts don't work anymore. For example, we have the prominent connectivity change event, and you won't receive a broadcast anymore if you register your broadcast receiver inside of your manifest file. If you're doing this programmatically, then everything is still working again, but not with the inside of the manifest file. And the reason for that is simple. Imagine you have 8 apps on your device, and all of them are listening for the connectivity change event. What will happen now if there's a connectivity change? Then the Android system has to start every app out there, has to notify them that the connectivity change happened. And it's often the case that those events are sent after another. So we have multiple connectivity change events. And the Android OS has to do this over and over again. It has to stop applications, and not all of them will fit into the memory. So it has to stop them again. And it's really intense. It's not only for the battery life, but also for the performance of the whole device, and it could be slowing down the whole system. And this change really hit us in our application. So we have something like this in our application. It's an older code base, and we relied a lot on custom intents. So we have a note-taking app, and we send an intent once the user created a note, and other services could do something in the background after that. And it's important to understand that Google introduced a whitelist. They didn't add a blacklist where they said, oh, those intents aren't working anymore. No, they only have a subset of intents now which are still working. And this also means that your custom intents stop working. And of course, there are also, again, workarounds. And one solution for us that worked really well is that we created our own permission. And all of our broadcast receivers, which we registered in the manifest file, have this permission automatically. And in the end, we just send a broadcast with this permission, and our own custom intents started working again. So this is a nice workaround and could be used easily. Okay, so now let's get more to the real APIs, which help you to deal with Doze and App Standby and other restrictions, which I was talking about. And I think it's always the easiest to introduce those APIs with a sample. So let's create a simple reminder app. The user should be able to create reminders. And of course, we want to sync them with the server. And at a given time, we want to show a notification when the reminder should be appearing. So nothing fancy. And since this is a really simple app, the application should work on all devices out there. And of course, we try to implement this at the best way, and we don't want to waste any resources unnecessarily. So let's start with the reminder job. The reminder job, the most important requirement is that it must be exact. So we want to show the notification at a given time. We don't want to show it 5 minutes earlier or 10 minutes later. No, it must be exact. Then we can have multiple of them at the same time. So the user can create 4 reminders. And then we need to have 4 reminder jobs also. And for this, we only have one API, and that's the Alarm Manager. So let's start with this. The good thing about the Alarm Manager is that it's available on all devices out there. It exists since version 1 of Android. And it's really easy to send broadcasts or to start services delayed. The downside of it is that the API behavior differs between platform versions, and we will see this in a second. Then you have to write a lot of boilerplate code, and the device data is ignored. So you can't have requirements like start a service only if we have a working network connection. But let's take a look at the implementation. I will go quickly over this. This is nothing new. Like I said, this code would work on Android 1. So just to give you an overview how painful it is how to implement all those APIs. So for our reminder job, we start with a receiver. We register the receiver in our manifest file. Then we actually extend the broadcast receiver class, and that's it. That's nothing new. You probably all know that. But more interesting is how we are scheduling the job so that we really see the notification at a given time. And for the Alarm Manager, what you usually do is you create an intent, you wrap this intent inside of a pending intent, and then you pass this intent to the Alarm Manager. What I'd like to point out here is how the system compares pending intents. So in our application, the user can cancel reminders again. So we also need to cancel our reminder job. And if you want to cancel an intent inside of the Alarm Manager, then you have to create the same pending intent over again. And it's important to understand how the system compares pending intents. And one thing which is important is the component which you are targeting. In this case, we have the reminder service, and then also the request code for the pending intent is important. On the other side, for example, the extras inside of your intent, they are ignored. They are not important at all. Okay. Then once we created the pending intent, we set it at a given time inside of the Alarm Manager. Okay, imagine we would have released this app 4 or 5 years ago. Everything was fine. But then Android KitKat was released, and suddenly our alarms weren't working anymore, and we saw the notification sometimes a little bit too early or too late. And the reason for this is that with Android KitKat, the semantics of the set method has changed. So before that, on older versions, alarms were always exact. But now they are inexact. And instead, we have to use another method, which is called setExact. So, like I said, our reminders need to be exact, and that's why we need to use this method. Then Android Marshmallow was released, and the same thing happened here again. So while the device is in Doze mode, our alarms didn't appear anymore, and we saw the notification too late. And again, there's another method, and this is called setExact and allow while idle. So allow sending the intent while the device is in idle mode, or basically Doze mode. So in the end, we have something like this. If we are on Android M or above, use the setExact and allow while idle method. On KitKat, use setExact, and otherwise use the old set method. And Google was also aware of the situation that this isn't really easy to understand and to follow. That's why they created a couple of years ago this flowchart. And in my opinion, if you have to create a flowchart like this to describe an API, that's not the nicest way. But in their defense, this API exists since Android 1, and of course the requirements have changed. Now let's get to our sync job. So we want to sync our reminders. This one has different requirements than the reminder job. It can be inexact, so we don't need to sync our reminders really every 6 hours. We can sync them sometimes in 4 hours or maybe in 8 hours. We don't really care as long as they are synced. On the other hand, the job must be repeating. So once we sync them, we want to schedule the job again. Then we only want to run the job in an unmetered network and while the device is charging. So we not only want to save battery, but we want to save the actual money for the user. We don't want to sync reminders in a roaming network. And then, of course, we don't want to wake up the device while it's currently in Doze mode. And here we have two APIs. That's the job scheduler and the GCM network manager. So let's start with the job scheduler. The cool thing about the job scheduler is that it provides a way nicer API than the alarm manager, and we will see this in a second. Then we can set certain requirements, like that the device must be charging. The downside of it is that it's only available on Android L and above. So below that, we can't use it at all. And then there are even some features only available on the even newer platform versions. And in the end, we still have to write a lot of boilerplate code, which is annoying. So I go quickly over the API. That's not that is interesting, actually. Here again, we start with a service, which we need to register in our manifest file. At the same time, I'm also requesting a permission, and we will see in a second why this is important. Then our job class, we have to extend the job service class. And here we have two methods. That's the onStartJob method and the onStopJob method. The only important thing to understand here is that both methods are called on the main thread. So if you need to do a network request, for example, then you have to spawn another thread and to do your actual work there. And once you're done with your work in your background thread, then you have to notify the job that you're done. But more interesting, again, is the schedule method. And let's go over it. So the first difference is that we have a job ID. So that's a fixed ID, which we set in our builder object. And later, if we want to cancel the job, we just need to know its ID. It's really simple and much better than the alarm manager. Then we can set certain requirements, like the device must be charging. And the third method, which I'm highlighting here, is the setPersisted method. So if a job is persisted, then it's automatically rescheduled if the device is rebooting. That's something we haven't talked about with the alarm manager yet. So if the device is rebooting, then all alarms are cancelled inside of your alarm manager. And you have to reschedule those alarms manually. That's a lot of work. And the job scheduler takes care of this with the setPersisted method. And that's why we were requesting the boot completed permission before that in the manifest file. After that, we call the setPeriodic method so that our job is running over and over again. And that's it. Now, with Android N, a new API or new method was released, or new overload for the setPeriodic method, and the new version accepts a flex parameter. And the flex parameter is important and actually really helpful, and we want to use it on newer versions. And why it's important, you can see this here. So the requirement of a periodic job is that it should run once during each interval. So it could happen that the job runs at the beginning of an interval, and during the next interval, it runs at the end. So the gap between both runs is actually bigger than our period. And the flex parameter is helping here. So it reduces the time frame when the job is allowed to run. So in this case, we had a flex value of 3 hours and a period of 6 hours. So the job is only allowed to run with this offset and not earlier than that. So that's helpful. Now let's get to the GCM network manager. This is an alternative for the job scheduler. Like I said, the job scheduler is only available on Android L and above. But below that, we have the GCM network manager. It provides a similar API like the job scheduler, and it's available on all devices basically out there. The problem, however, is that it's part of the Google Play Service SDK. So if your device hasn't the Play Service installed, then you can't use this API. For example, that means that most Chinese devices wouldn't be able to use your app if you rely on this API. Again, the implementation, it's really similar like the job scheduler. So the first thing, again, we need to do is we create our service inside of the manifest file. Then we have to extend a service class. And here we only have to override one method. That's the onRunTask method. And this one is already called for us on the background thread. So we don't have to create another thread for this task. And the scheduler method, like I said, it's really similar to the job scheduler. The important part here is that we use a tag instead of an ID, so that's not a big deal, just something to be aware of. And the GSM Network Manager supports the flex parameter on all devices, so of course we want to use it here. The big difference for is that we are using seconds here. We are not using milliseconds. So if you don't read the documentation carefully, then you schedule your job and you wonder why your job isn't running at all, simply because you scheduled it too far in the future. Yeah, you just need to be careful and have to be aware of it. Otherwise, it's not a big deal, but it really hit us. Okay, and then, like I said, Job Scheduler is only available on Lollipop and above, GCM Network Manager only with the Google Play services, and we want to support all devices out there. So again, we have to use the Alarm Manager as a fallback. And I stop here because I promise you, it's as much fun as the reminder job. And here, in the end, we have something like this. If we are on Android N and above, use the Job Scheduler with the flex parameter. On Lollipop and above, use the Job Scheduler without the flex parameter. Below that, use the GCM Network Manager if the Play services are available, and otherwise use the Alarm Manager as a fallback. So you have to write a lot of code. Just for the sake of completeness, I'd like to mention a few other APIs, but I won't go any deeper at them. So Google released the file-based job dispatcher, and the idea of the job dispatcher is that it's a wrapper around the existing job schedule engines, like the Job Scheduler or the GCM Network Manager. The problem of is that it was really difficult to set up in the past. I think this has changed recently. Then the library isn't really maintained. There are a lot of open issues. And the biggest complaint, in my opinion, is that it only supports the GCM Network Manager at the moment and not the Job Scheduler. So again, if you don't have the Google Play service installed, then you even can't use the file-based job dispatcher, and you basically could use the GCM Network Manager directly. Then we also have the job intent service. The job intent service came with the new Google's support library, and it's really meant as a replacement for the intent service. And the good thing about the job intent service is that it respects the device state. So if your application is currently in the background, then you can't use an intent service. Like I said, with the new background execution limits, your app would crash. The job intent service is handling this for you. So on Android O and above, it's using the job scheduler under the hood, and before that, it's using a normal intent service. Then it automatically creates wake logs for you. This is really handy. But it's not really a job scheduler engine. It's just meant as a replacement for the intent service, and you can only start jobs now and not, for example, delayed. So you can combine the job intent service, for example, with pending intents. That doesn't work. Okay, so in the end, we have to write a lot of boilerplate code to achieve something that should be really simple. And if there is something that's so hard and should be simpler, of course, there must be a better solution than that. Unfortunately, there is one, and this one is called Android Job. That's a library I've created at Evernote, and before Android M was released, and we had the same headache. We couldn't implement for every job or task we had a separate job with the job scheduler, then a fallback with the alarm manager, then you have to handle the rescheduling, and it was a mess. And that's why we created the library, and it's really solving all those pain points. So it provides a single API for all the existing APIs which are introduced, so for the job scheduler, the GCM Network Manager, and Alarm Manager. It supports all the features from Android O, and all of them were backported. And it automatically chooses the best API for your job. So you just define the requirements, and then we decide what's the best API for that kind of job. In the end, this means for you that you have to write less boilerplate code, and you just implement your job, and you're done. And of course, there are more benefits than that. So let's look at the API so that we can see all the features. The first thing that's different is, or which we decided to use, is that we have a tag again for the job. And you will see in a second why this is important. Then we have all the timing requirements, like we could define a time window if a job should run only once. Then we have a setExact method in case the job needs to be exact, and so on. Then we can define a backup criteria. That's also something we haven't talked about yet. What happens if a job fails for some reason and you want to try to run the job again in 1 minute or in 1 hour? Then you have to basically reschedule your job manually again, and it's really, really annoying. And here you can define a backup criteria and you're done. Then we have all the requirements, also the new requirements from Android O, for example, that the job shouldn't run if the storage is not low or the battery is not low. Then we can pass extras to the job easily, for example, string values or other values inside of the bundle. And then we have the set update current method. This one is helpful if you only have one job for a specific kind, like our sync job, where we only need to have one. Then if you schedule a new job, then it automatically cancels the old one. In the end, you call build and schedule on your builder, and this returns the job ID for your job. So let's look how we can implement our reminder app with the Android job library. So the first thing you need to do is you need to add the dependency, and then you have to create the job manager. The best place to do this is inside of your application class. You call create on the job manager, and then you add your job creator. The job creator is a really simple interface. It's basically just a mapping from your strings or your job tags to your actual job class. This is basically replacing the manifest entry. And on the other side, it's much more flexible than that because it's code and you can change this if you want. So let's start with the reminder job again. With the job library, what you need to do is you have to extend the job class, what we see at the bottom, at the top, and then you have to override one method, and that's the onRun job method. This method, again, is already called on a background thread for you. A wake clock is automatically acquired for you so that you can just start doing your work. And in the end, you return a result. Again, more interesting is the schedule method. And from reminders, it's really simple. Like I said, I'm using the tag here. Again, that's the tag which you need to use in your job creator interface to map it to your actual job class. And then on our creator, we call setExact. So we only have to do this once. We call setExact, and the library will make sure that the job will run at the given time you are setting. And you don't have to deal with any API checks at all. And that's basically it for the reminder job. So we can start with the sync job again. And this one is even simpler than that. We just can start syncing our reminders, and we don't have to care about creating a thread or anything like that. The schedule method looks a little bit scary at the first moment, but it's actually not. So let's go over it. The first thing I'm doing here, I'm checking if there's already a sync job scheduled. If there isn't one, then I stop here and I don't need to do anything because we only need one sync job. If we already have one, we don't need to do anything. Then we call the setPeriodic method. Like I said, the flex parameter was backported to all devices, and we can use that. Then we go quickly over that. Time's running out. Then we can set the requirements, like devices should be charging, and we should need an unmetered network. And then we are done. That's basically our reminder app. So we have to implement those jobs only once and not do any platform checks at all. So who's using the library? For example, Dropbox is using it, Twitter is using it, we have Pocket, then the New York Times, since we're in New York, is using it, and of course we do at Evernote. So I'm often receiving the same questions over and over again about the libraries. So let's do a little FAQ and ask the most important questions. So which API is used? Well, it actually depends on your job. So if you have an exact job, then we are using the alarm manager, simply because there's no other way. Then on API 21 and above, we are using the job scheduler. If the play services are installed, we use the G7 app manager, and otherwise the alarm manager. What happens after a reboot? After a reboot, all of your jobs are rescheduled automatically. So you don't have to care about it. All your jobs really will run. If you want to cancel a job, then you manually have to call cancel with the job manager. This is also the case after forced closing your app. I don't know if you're aware of that, but if you're forced closing your app, then all your alarms are cleared. And the library is taking care of this and reschedules your alarms if it needs to do this. So it's really hard to do this otherwise. And there are other cases where jobs need to be rescheduled. Then my periodic jobs are running as expected. I often hear this question over and over again. So the solution for that is that you have to keep those and the system in mind. The library isn't fighting the system and trying to prevent that the device goes into Doze mode. So if you have a periodic job that should run every 50 minutes, this simply won't be the case. So if the device is in Doze mode, then your job will be delayed by 1 hour or even more than that. And your job really won't run every 15 minutes. If you need to have a job to run every 15 minutes, then you might want to reconsider your requirements. How can I run an async operation? The answer is simple. Simply block the background thread inside of your onRun job method. What happens if my job crashes? Then the result is treated like a failure. So if you throw an exception inside of your job, then the library thinks it's a failure and your job won't be rescheduled. Can I reuse jobs? I don't know why, but for some reason people always want to reuse their jobs, and this won't work. Just create a new job inside of your job creator interface. And if you have to do any heavy lifting by setting up your job, then you can do this inside of the onRun job method. I will skip this actually. Transient jobs are a new API in Android O, and we also backported it, so you can use a real bundle with your jobs that works on all devices out there again. Then how can I run a job once a day? We have a helper class for this. That's the daily job class. It's really simple to use, and then you can make sure that really a job runs once each night. Then how can I test jobs? It turned out for us that the easiest way is to have a QA setting, and our QA team could schedule jobs manually in the side of our application. Then you can also inspect the database. So we store all the jobs inside of a database, and you can double check the values there. And then you can also use ADB. So you can also test Doze mode through ADB. There are just 2 commands for that, really simple. And yeah, last but not least, if you have problems, feel free to create an issue, and I try to answer them as soon as possible. So again, the Android API forces you to do the same thing over and over again. You have to write a lot of boilerplate code, and here is where Android Shop comes to the rescue and helps you. Thank you.